Assalamualaikum warahmatullahi wabarakatuh. My name is Norhani binti Kamaruddin and I am from ED2485A. My topic for assignment is radiation vulcanization. Let's go definition of radiation. Radiation is energy that comes from a source and travels through space at the speed of light. This energy has an electric field and a magnetic field associated with it, and has wave-like properties. Energy emitted from a source is generally referred to as radiation. There are various types of radiation, which are alpha radiations, consists of heavy positively charged particles emitted by atoms of elements such as uranium and radium. Beta radiations consist of electrons. They are more penetrating than alpha particles and can pass through 1 to 2 centimeters of water. Gamma rays are electromagnetic radiation similar to X-rays, light and radio wave. Gamma rays, depending on their energy, can pass right through the human body but can be stopped by thick walls of concrete or lead. Neutrons are uncharged particles and do not produce ionization directly, but their interaction with the atoms of matter can give rise to alpha, beta, gamma or X-rays, which then produce ionization. Although we cannot see or feel the presence of radiation, it can be detected and measured in the most minute quantities with quite simple radiation measuring instruments. Next is definition of vulcanization. Process of treating rubber or rubber-like material with sulfur at great heat to improve elasticity and strength or to harden them. The process of vulcanization involves extreme heat, in addition to the application of chemicals, usually sulfur. Vulcanization is a process that changes synthetic and natural rubber into cross-linked polymers. Sulfur is a vulcanization agent for a natural rubber into cross-linked polymers. Cross-links, which form bridges between the chains, are stress-bearing members contributing to elasticity and strength. Vulcanization of rubbers by sulfur alone is an extremely slow and inefficient process. The chemical reaction between sulfur and the rubber hydrocarbon occurs mainly at the double bond, and each crosslink requires 40 to 55 sulfur atoms in the absence of accelerator. The process takes around 6 hours at 140 Celsius for completion, which is uneconomical by any production standards. The vulcanics thus produced are extremely prone to oxidative degradation and do not possess adequate mechanical properties for practical rubber applications. These limitations were overcome through invention of accelerator. 5 common types of vulcanization agents are sulfur or sulfur compounds, metallic oxide, peroxide, acetylene, and urethane. Radiation vulcanized natural rubber latex is a rubber latex vulcanized by using ionizing radiation such as gamma radiation or electron beam. Gamma radiation is preferred over electron beam due to its higher penetration power, and cobalt-60 is commonly used as a gamma radiation source for the irradiation process. Caesium-137 is another source for gamma radiation, but it is not commonly used for this preparation, despite its longer half-life. Caesium-167 retains its source activity much longer than cobalt-60, and a caesium-137 based irradiation facility would require less replenishment compared with the one with cobalt-60. Radiation-induced cross-linking of natural rubber in latex can be accomplished by irradiation and arc latex. One of the reasons preventing the application of caesium-137 for this preparation is its lower gamma radiation energy. Despite its lower dose rate radiation energy, The effectiveness of calcium-137 is higher than cobalt-60 when the source is used to vulcanize latex at radiation dose below 12 kg. In natural rubber latex vulcanization, the use of gamma radiation helps to simplify the process, produce cleaner vulcanized natural rubber latex, and hence deep latex product. The vulcanizates of radiation vulcanized natural rubber latex meet the current specification required for deep product. These films vulcanizates have the tensile strength of about 28 megapascal and an elongation at break of about 1000%. Next, the process of crosslink. How is sulfur crosslink? Rubber molecules have double covalent bonds. Sulfur atoms react with the double bond in the rubber molecules chain to form CSSC crosslink between the rubber molecule. Let's see this video.
Here, cross-link, carbon, sulfur, sulfur, carbon, CSSC, carbon, sulfur, sulfur, carbon. So you add sulfur, then it will form a cross-link. Okay, this carbon and this carbon, it will form a bond. So it has this CSSC cross-link. Now, initially for natural rubbers, this rubber, they can slide over each other's, right, when you stretch it. But after you add the sulfur, this sulfur form a bond between these molecules, and now it's very hard for us to break this bond. So then this is called vulcanized rubber. So that's the difference between natural rubbers and vulcanized rubber. Vulcanized rubber, we add sulfur, and the sulfur form the CSS cross link between the rubber molecule, and this make it become more elastic and stronger. Okay, in exam they may ask you to draw the structures of the vulcanized rubber, so make sure that you know how to draw it.